All right, in today's video, we're going to be looking at 14.6, solving rational equations. So you're going to start off by being presented by questions that look like this. It's going to say x minus 7 divided by 2x equals 8 divided by 4x. These are problems I like to call proportion problems, which is cross multiply and divide. But really and truly, we're just going to focus on the cross multiplying. What side you put it on does not matter. So and it doesn't matter if you go, right to left, left to right first. That part doesn't matter either. But do make sure you go from the bottom right to the top left and the bottom left to the top right. That part does matter. So I'm going to do 4x times x minus 7. So it's going to look like this equals 2x times 8. What you put in parentheses doesn't matter. I'm just showing you that it's multiplication. So now I'm going to distribute. 4x times x is 4x squared. 4x times negative 7 is going to give us 7, 14, negative 28x. And then 2x times 8 is 16x. So our goal here is to then solve this using our factoring techniques. But before we can do that with quadratics, we have to set it equal to 0. So I'm going to subtract 16x from both sides. This gives us 0. 28 minus 6, or negative 28 minus 16 was at 38, negative 44. And then bring down the 4x squared. I can see that they both have a 4 in common and an x in common. So I'm going to divide everything by 4x. And when I do that, that gives me x minus 11 equals 0. Then we set each factor equal to 0. I'll divide by 4. So x gives me 0. And then I'll add 11. So x equals 11. Now, one thing, just like we saw with the radicals, you do need to figure out what x cannot be. And I think we did this at the beginning of chapter 14 as well. So I can see what I have to do is I have to take each denominator and set it equal to 0. So that's going to be 2x equals 0 and 4x equals 0 to figure out what x cannot be. So I'll divide by 2. So x can't be 0. And x still can't be 0. So since x can't be 0, this is not part of the solution, and x equals 11 would be my only answer. All right, so let's try another one. So this will be part B. We have 3 over x minus 6 equals 5 over x. And then we're going to cross multiply. X times 3 is 3x. And then x minus 6 times 5, I'm going to write it as 5 times x minus 6 so that I distribute. This gives me 5x minus 30. And then now I'm having a linear equation, so I need to figure out which way I want to solve this. I like to move the smaller x over, but you can move in whatever direction you like. I'm going to subtract 3x. And I think at the same time, I'm going to go ahead and add 30. The reason I'm going to do that is that gives me 2x. It goes ahead and gets rid of that constant. If you want to do that in a separate step, that's perfectly fine. Because then at this point, all I have to do is divide by 2, and I get x equals 15. But we need to check what x cannot be. We take each denominator and set them equal to 0. So x minus 6 equals 0, and x equals 0. So I'm going to add 6. So x cannot be 6, and x cannot be 0. Well, 15 is neither one of those, so 15 is the answer. All right, in this one, though, there is some application problems, so let's look at some of those. So on number 2, it says on a scale of a map of a highway, 1 inch will represent 60 miles. So that's wanting to know, well, what length does a measure of 3 3/4 inches represent? So how many miles would that be? So you're basically going to set up a proportion. Best way you can set up a proportion is pick a unit. Go inches over miles or miles over inches. It does not matter. But whatever you set here will be what needs to be consistent throughout your problem. So I have 1 inch. I'll be 1 on top, 60 miles. So that'll be 60 on bottom because inches is on top and miles is on bottom. We decided this part, so that part's completely up to you. But once we make that decision, the fraction then deals with whatever it is. Inches on top, I have 3 3/4. If you didn't know, this mixed fraction is actually 3.75. Because 3/4 is 0.75, is 3/4. So this is 3.75 over, I don't know how many miles. So that's going to be my x. Now I have what I was just dealing with on question 1. So I'm going to cross multiply. So 1 times x is x. And then 60 times 3.75 would be 225. As long as x isn't 0, because that's what the only thing that x cannot be. So x cannot be 0. And of course, 60 is just a number. And 225 is not 0. So that would mean that x equals 225 miles. So if you're looking at a map key and you see that it says 1 inch equals 60 miles, and you measure out a distance from your destination, and you see that's 3.75 inches away, that's actually 225 miles you'd have to travel. So we have to used to do with those orange books of key maps, or those who may or may not remember those. All right, number 3, we're going back to just regular solving equations, and we'll bounce back in some more of those application problems. But in this part of the homework, it's going to first now ask for the restrictions. Question 1 did not ask for the restrictions, but we still had to go find the restrictions so we could figure out what x still can't be. Here, it wants us to do that step first. So we have 1 over x plus 2 equals 6 over x squared plus 7x. So my first task is to figure out what x cannot be. So that's going to be x plus 2 equals 0. So I'll subtract 2. So x cannot be negative 2. And then I have x squared plus 7x equals 0. So I'll factor this first. So it gives me x and x plus 7. And I'll set each factor equal to 0. X can equal 0. Subtract 7. And x can't equal negative 7. So x cannot be the value of negative 2, 0, or negative 7. So now I'm ready to go back and solve this by cross multiplying. So x squared plus 7x times 1 would just be x squared plus 7x. And then that becomes 6 times x plus 2. So I'll distribute that out. So it gives me 6x plus 12. I'm dealing with a quadratic, so I need to set it equal to 0. So I'm going to subtract 6x, and I'm going to go ahead and subtract 12 as well. That gives me my equals 0. This gives me x squared. 7x minus 6x is just plus x minus 12. Now I have to figure out, well, what multiplies to negative 12 and adds up to 1. So a trinomial will factor into 2 binomials. The thing that multiplies to negative 12 and adds up to 1 will be 3 and 4. So that's going to be a positive 4 and a negative 3. If you need to do the t-chart to kind of figure out your numbers, go ahead and do that. But now I'm going to set these equal to 0. So I get x minus 3 equals 0 and x plus 4 equals 0. So I'm going to add 3. So that gives me x equals 3. And then I'm going to subtract 4. That gives me x equals negative 4. 3 and negative 4 are none of the values x cannot be, so both of these would be the answer. So the beginning of your process, you got to figure out what x couldn't be, so all 3 of those is what x cannot be. And then you solve it, and then you find out that these 2 answers is what the value of x actually is. Let's look at a more complicated question now. So what we've seen so far are what we like to call proportion questions, which you simply just cross multiply and then solve. They get way more complicated, so let's look at ones that are. So we have x over x minus 2 plus 4x minus 4 over x minus 2. Oh, sorry. X times x minus 2 equals 6x over x minus 2 minus 8 over x minus 2. All right, so first thing you have to do is figure out your restrictions. So I have have x minus 2, and I just have an x. So the rest of this is all the exact same thing. So I'm not going to solve it 15 times. So I have x minus 2 equals 0 and x equals 0. So x cannot equal 0. Add 2. So x cannot equal 2. So those are where x's cannot be. So what we like to do here is no one likes fractions. So what we do is we figure out, well, what's the least common denominator? Meaning, if I have to multiply all of these by an x to get rid of it, then that's what I'm going to do. So in a sense, this is what we do. We determine there's an x minus 2, so I'm going to multiply by an x minus 2. There's an x, so I'm going to multiply by an x. Then I have x minus 2 again, so I'm not going to write it down again. I have an x minus 2 again, so I won't write it again. And I have another x minus 2, so I'm only going to write it down one time. So what we do with this, we wrote every single factor one time. And now I'm going to multiply each fraction by this denominator. Now, I'm going to show you what it looks like overall, and then I'm going to show you how you can quickly kind of go through this. So this becomes x times, oh, let me write this in pink. So we'll do, here's your original stuff. Now I'm going to multiply by this denominator to everything. So there's now another x and x minus 2, x, x minus 2, x, x minus 2, x, and x minus 2. So as long as I'm multiplying everything by the exact same thing, I can do this. I haven't changed the value because I've done it to every term. And now I'm going to cancel what's in common. I notice the x minus 2 is in common. This one has an x minus 2 and an x in common. This one has an x minus 2 in common, and this one has an x minus 2. Now notice what happens. I have x times x, which is x squared, plus 4x minus 4, no more fractions, equals 6x times x, which is 6x squared, minus 8 times x, which is 8x. So the purpose of doing this is to get rid of all the fractions. Now I can solve this as a regular polynomial equation. Okay. And again, this is a quadratic, so I need to get everything over, and I'm going to move it to the larger side. So I'm going to subtract x squared, subtract 4x, and add 4. Six x squared minus x squared would be 5x squared. Negative 8x minus 4x is negative 12x plus 4. So this is what I have. So then when I do my t-chart to solve this, remember it's a times c. That's going to be 5 times 4, which is 20. That's what I'm trying to multiply to. And I'm going to add to negative 12. So it's not 1, so 1 and 20. And they to multiply to a positive but add to a negative, both of them have to be negative, so that's negative 21. Then I have negative 2 and negative 10, so that's going to be negative 12, which is what I wanted. So then this right here becomes x minus 2, x minus 10. Remember, if there is a leading coefficient that's not a 1, I have to divide that by 5, or by the a. And if I can't simplify it, it goes up to the front. 10 divided by 5 is, in fact, 2. So this gives me 5x minus 2 and x minus 2. Now I'm going to set each one of these equal to 0. So I'm kind of running out of room. So this is going to be 5x minus 2 equals 0, and x minus 2 equals 0. So plus 2. So 5x equals 2, then divide by 5. So x equals 2/5. And this one's plus 2. So x equals 2. But hold on. I found out at the very beginning, x cannot equal 2. So that one goes away. And my only answer would be x equals 2/5. So this is it actually gets harder than this, but this is where these type of problems usually are at. All right. With that said, let's try to get another step in. So let's look at number 5. Number 5 says 4 over x squared minus 25 equals 2 over x squared plus 2 over x squared minus 5x. So the first task I'm going to do is factor each one of my denominators. So x squared minus 25, if I'm multiplying to a c and adding to a 0, I know I'm going to have two of the same numbers. One with a positive, one with a negative. And then that would have to be 5. 5 times 5 is 25. So that goes away. X squared stays. And then I can see that they both have an x in common. So that'd be x minus 5. All right, so here we go. So let's start off by figuring out what x cannot be. So I have, and well, technically, let's do this. X squared technically is x times x. This will help us out a little bit later. So I have an x plus 5 equal to 0. I have an x minus 5 equal to 0. I have an x equal to 0. I already have an x, so I'm not going to write it again. Have an x, not going to write it again. And have an x minus 5, not going to write it again. So I'm going to subtract 5. So x cannot be negative 5. So x cannot be 5. And x cannot be 0. Now, all the ones I just set equal to 0, those are my least common denominators. So that means when I multiply this out, I'm going to multiply by an x plus 5, an x minus 5, and an x. I'm going to have to multiply by 2 of them. If this shares one, but it's going to need a second one. Now, I'll show you how I know that. So let me write out everything first. And this will help you too, just in case you miss something. All right, let me say I didn't notice I'm going to need another x. So I'm going to multiply by what I think is the least common denominator. X. Oh, having technical difficulties. Give me 1 second. All right, back. So this will be x plus 5, x minus 5, and an x. This would be x plus 5, x minus 5, and an x. This would be x plus 5, x minus 5, and an x. So now when I go cancel, I can cancel, I can cancel. Great, that worked out. And then when I get here though, I can cancel, but I can't cancel everything. Because when I get here, I can cancel and I can cancel. I have to be able to cancel everything. So because I'm still having one x, that tells me I need to multiply by another x. As long as I do it to every single one of them, I can now also cancel that. So now I actually get 4 times x, which is actually 4x squared. Then I have 2 times x plus 5 times x minus 5, which we know is x squared minus 25, plus 2 times x plus 5 times x. So let me clean this up. This gives me 2x squared, negative 50. And what I'm going to do is I'm actually going to multiply the 2 and the x at the same time. So 2x, or 2 times x is 2x times x is 2x squared. 2 times 5 is 10 times x would be 10x. If you want to do that separately, multiply by 2, bring it down, then multiply by x, that'll work too. Now I'm going to combine like terms. So 2x squared plus 2x squared gives me 4x squared plus 10x minus 50, just put it in order. It's a quadratic, so I got to set it equal to 0. So that gives me 0. That actually cancels 2, and I get 10x minus 50. So I now have a linear equation. So I need to get rid of my constant first. So I'm going to add 50. Then I'm going to divide by 10. So I get x equals 5. And earlier I wrote 5 cannot equal 5. I meant to say x cannot be negative 5, x can't be 5, and x can't be 0. So x cannot equal this 5. So in a situation like this, we note that there is no solution. So we've done all this work to find out that there actually is no way to solve this. Or it's unsolvable is really what it comes down to. All right, let's do another one. Make sure you have plenty of examples. Looking at number 6, we have 4y squared over y squared plus 3y minus 10 equals y plus 1 over y plus 5 plus 3y, 3y over at y minus 2. I start by factoring. So this right here is going to turn into 2 binomials. Oh. All right, so 2 things that multiply negative 10 but add up to 3 is probably going to be 5 and 2 just by looking at these hints. And I see it's probably a positive 5 and a negative 2. So that goes away. The rest of it's factored. So I'm going to take y plus 5 equal to 0, y minus 2 equal to 0. Not going to write it again, not going to write it again. So let's subtract 5. So y equals negative 5. Add 2. So y equals 2. So y cannot equal these values. I cannot equal negative 5, and I cannot equal 2. Now I'm ready to determine what I'm going to multiply by. And again, I'm going to start with the things that I said equal to 0. So that's going to be y plus 5 and y minus 5. Nope, I lied. That was a y minus 2. And I'm going to do it to each one. So this becomes, let me write this. 4y squared over y plus 5, y minus 2 equals y plus 1, y plus 5 plus 3y over y minus 2. This then gives me y plus 5, y minus 2, y plus 5, y minus 2, y plus 5, y minus 2. Plus 5s will go away, minus 2 goes away, plus 5 goes away, minus 2 goes away. Everything on bottom did get canceled, so I did good on my least common denominator. So that gives me 4y squared equals y plus 1 times y minus 2 plus 3y times y plus 5. All right, let's get this distributed. You could do box method or FOIL, however you want to look at it, but y times y is y squared. Y times negative 2 is negative 2y. 1 times y is 1y. 1 times negative 2 is negative 2. 3y times y is 3y squared. 3y times 5 is 15y. Combine like terms, you get 4y squared equals 4y squared. That's going to be negative y plus 15. That's going to be plus 14y minus 2. Oh. All right, so I'm going to start off by subtracting 4y squared, set this equal to 0 since it's a quadratic. But then I notice I get 0. Nope, I don't need to write the 0. So I'm left with 14y minus 2. So now I'm left with a linear function. So I'm going to get rid of my constant first by adding 2. So I get 2 equals 14y. Divide by 14. And that will simplify to 1/7 equals y. And 1/7 was not a value that it could not equal. So I'm good there. All righty. Let's see. All right, so let's jump back to some application problems now. This one has the surface area of a rectangular box is given by a formula. So you're given surface area equals 2 times length times h plus 2 times width times h plus 2 times length times width. And it asks us to solve for length. This is one of those literal equations that we dealt with in chapter 9 that we kind of struggled with, but it's coming back, so you'll have to see it again. First thing we're going to do is get everything multiplied. So this would be 2LH, no longer needs the parentheses, 2WH, and 2LW. Nothing in common, but if I'm solving for L, I want L on one side and everything else to the other. So these two have an L, so I'm going to get rid of the 2WH. So I'm going to get rid, so since it's a plus, I'm going to subtract 2WH. So that's going to be SA minus 2WH. And now I'm going to factor out an L because they both have an L in common. And when I do that, I'm left with 2H plus 2W. Now this is technically being multiplied to L, so to get rid of it, I'm going to divide it. So this goes away, and I now have an equation for my L. To find the length, I can take the surface area minus 2 times the width times the height and divide it by 2 times the height plus 2 times the width, if I knew those values. All right, so remember when solving literal equations, you're not getting a number, you're just getting another equation. All right, let's look at another type of application problem. Let's take a look at number 8. Number 8 says you have two triangles, A, B, C, and P, Q, R. It says now assume ABC and PQR are similar. And on ABC, the length for AB is x minus 4, and the length for BC is 5. And on PQ, it is 9. And on QR, it is x. And it wants us to solve for x. So when we're doing this guy divided by this guy. So what I'm doing is I'm going to do this length divided by this length is x minus 4 over 5. And I can do that as long as I do the same side. So if this side corresponds to this side, then that needs to be on top. And if this side corresponds with this side, that needs to be on bottom. Now, you could have done this in multiple ways. We could have done 5 over x minus 4, but then it'd become x over 9. Some people might have done x minus 4 over 9, which is fine, but then it needs to be 5 over x, and you started with this triangle, then went to this triangle. Or you could flip-flop that and said, well, that's just 9 over x minus 4 equals x over 5. Multiple ways to set these up, as long as you're staying congruent. So if I start on this triangle and I went this length, then I stayed on this triangle and I went this length, that's perfectly fine. But then I have to go to this triangle and I have to do the corresponding length with its corresponding length, right? So how you set it up is completely up to you, but you have to stay the same going into the second fraction. All right, so with all that said, we're now back to what we started with on question 1. So we're just going to cross multiply. So I get x times x minus 4, and then 5 times 9, which in this case is 45. And then I'm going to do distribute. So I get x squared minus 4x equals 45. It's a quadratic, so I need to set it equal to 0. So this gives me x squared minus 4x minus 45 equals 0. And now I got to determine two things that multiply to negative 45 and add up to negative 4. First numbers that come to my mind is 9 and 5. That multiplies to 45. And if my 9's negative and my 5 is positive, that'll make it a negative and add to negative 4. Again, if you have to do your t-chart, do it. And so then get x minus 9 equals 0 and x plus 5 equals 0. So I'm going to add 9. So x equals 9, subtract 5. So x equals negative 5. Now, when dealing with real world problems, you do have to think of the answer being realistic. So in this situation, it is not realistic for a length of a triangle to be a negative value. We don't ever measure distance in negative numbers. So if you're dealing with a real world situation and you end up with a negative answer, about 99% of the time, you can throw that question out or that answer out, and it's going to be the other answer. So in this case, it would be 9. And when you plug it in, we realize that this will be 5 and 5 and 9 and 9. I also realized, too, that my triangles are misproportioned. APC should be smaller than PQR, but my goal was just to kind of draw a picture for me to plug in the information that was given to me. All right, so that's about it for 14.6. So if you have any questions, again, feel free to email me. Other than that, I will see you in the next video. Bye for now.